Okay, I guess we have everyone here already. So I'm just gonna go ahead and share my screen. Oh, oops. Oh, and also I'm gonna just drop the link in the chat. I believe it's shared with everyone, so you guys can look over the slides if you don't really understand like some part of it or just ask me questions. Yeah, let's start. So today is our third lesson of Introduction to Java. So let's look at the topics we'll be covering. Today's topic is gonna be pretty important because we're gonna talk about relational operators, if statements, for loops, while loops, and some more additional keywords. So this is they are all really important because even if you will be like doing really difficult programs in the future, you still have to use some of these. Yeah, let's first look at some relational operators. They're used to compare one number to another and then return a Boolean value. So a Boolean value is basically is just true or false. It determines if like this statement is true or it is false. So there are six main relational operators. Like the first one is the equal sign, double equal sign, which tests if the left side is equal to the right side. Notice that it's different from the equal sign, like it has two equal signs. So a equal sign would just output a value, while this one, it outputs like whether it is true or not. So on the first one, you can see that 2 plus 2 is equal to 4, and you know that's true because 4 is equal to 4. And the second one is the opposite to the first one. It means not equal to. It's indicated by like this little exclamation mark. So 3.2 and 4.1. We all know that they're not equal, right? Since they are not equal, this would return true because it satisfies the condition that the left side is not equal to the right side. The third one and the fifth one are just really similar. One is less than or equal to. Some of you guys might heard that in the math class. So basically 4 is less than 3, that's false. And 2 is greater than or equal to 0, which is also false. And similarly, this one and this one means greater than or equal to. 4 is greater than 3, that is true. And 2.4 is greater or equal to 1.6, and that's true as well. So, and then there are some Boolean logical operators. For example, we have this exclamation mark, which just means not. As we can see earlier, not equals means not equals. So we can see that this symbol means not. And the double, this symbol, I don't know what's called, but this symbol means and. It will only return true if both the conditions has to be true. We're gonna look at examples later, so just remember. And this is the two lines means or, so only one has to be true. So let's look at some examples to get it more clear. So first, let's see. True is a Boolean value, right? Boolean value only has true or false. So true is a Boolean value, and we add the exclamation mark, which means false. Or the opposite. What's the opposite of true? It's false, right? So that's how it is. As for this one, if you remember, this double equals means like test if the left is equal to the right. So from over here, we know that 3 is equal to 3. So this part will be true. And this one means and 3 is greater than 2. That is true as well. So true and true will output true. So as this one is similar, except the first statement is false. 3 is not equal to 2, right? So it's false and true, which is equal to false. So remember we said earlier that for and, both conditions has to be true. But this one, the left side is false. So the statement outputs to be false. And finally, we have the last one. 3 is equal to 2, it's false. And 3 is greater than 2 is false as well, as we can see over here. However, the statement, the symbol in the middle is the double line, which means or. So only one has to be true. So, oh, I forgot to type the L. So there's a false and there's a true. And we have one true right here, which is right. So this statement will output true. So all of these will be used later if we're ever gonna test for using the while statement and if statements. Oh, before that, let's look at some examples. So yeah, let's look at the first one. Take a minute to look at it and just type your answers in the chat. Okay, actually, we might not have enough time to go through everything. So I'm just gonna do the first one with you guys. So 3 is less than 4, right? We all know that 3 is less than 4. That is true. Oops. But then there's an exclamation mark, which means not. So not true is equal to false. So the answer for the first one is false. For the 2, 3, 4, I might come back to it later if we have enough time. So I'm just gonna skip it for now. We can come back later. So, and then we have the if logic, or what we usually call if statements. So it allows a program to make a decision, and the decisions are yes or no questions. And then the statement will then, based on the Boolean value of the statement being tested, and then it can make some actions. For example, if the condition is true or yes, then it will perform one command, and if it's false, it will perform another command. So let's look at some real life if conditions we might face. So for example, if we say, oh, if today's raining, then I will bring an umbrella. Or if today's hot, then I will go to the swimming pool. These are like really logical decisions that you will make, right? So the bolded part, these parts are the conditions that need to be satisfied. And the red part is what would happen if the condition is satisfied. So for example, let's say today is sunny and not rainy. So you will not bring an umbrella. So you will do nothing. So this part will not get executed. And if today is not cold, I will not go to the swimming pool. So what the statement outputs based solely on the conditions that's being tested. For this one, the condition being tested is whether today is raining or not. And for this one is whether today is hot or not. And we have some different type of if statement. We have the statement that only uses the if loop, if statement, which executes the code only if the condition is true. There's only one logical possibility. For example, we may say, if today's hot, then I would wear a shirt. So if today's not hot, we don't know like what will we wear. We only know that if today's not hot, we will not be wearing a shirt. And there's a second type called if-else statements, and it sounds exactly like what you might think it is. It's pretty straightforward. So it executes one block of code if condition is true, or it will execute another code if the condition is false. So, but in the same context, if today is hot, then I would wear a shirt. Else, I would wear a sweater. So the else right here basically means if today is not hot. So for if, we're saying today is hot. Else, or you could interpret this as otherwise. So if today is hot, then I will wear a shirt. Otherwise, I will wear a sweater. Like if today is chill, warm, or cold, I will wear a sweater. Next, we have the if, else statements. So this one could have many different possibilities to choose from. Let's see an example. So if today's hot, then I will wear a shirt. Else, if today's warm, then I will wear a jacket. Else, if today's chill, I will wear a sweater. And else, I will wear a coat. So how is this different from the if else? So if I say today is warm, you could say that, oh, I'm gonna wear a jacket if we're on this page. But if we're on if else statement, if today is cold, if today's warm, I'll be wearing a sweater. For this one, if today's chill, I will wear a sweater. I mean, if I say, oh, today's cold, then if you're looking at if else statements, then I will wear a coat. But for this one, like any weather outside of hot, I will wear a sweater. So that's the main difference. This gives you more choice to choose from, which is the main reason why most codes usually use this one. Um, so, and yeah, then we have to talk about like when to use which. Like, how do we know like which one should we use? So let's say you want to write a program that prints the grade based on the score the student gets on the test. So let's look at the first code. So let's say if my score is greater than 90, I did pretty good on this test, I got above 90 score, then I will call the computer to print like, oh, student got an A, I will print an A on my paper. If score is greater than 80, I will print out a B. If score is greater than 70, I will print out a C or lower. So based on this code, do you think it's gonna, like, for example, if I input a student's test score, do you think it's gonna print the right, what we want it to print? Try to think about it. The answer is no, it will not always work. So let's say, for example, the student gets a score of 85. That's a pretty good score, but the student say, oh, I got an 85. So what will the machine print for me? So first, the 85 goes through here. Is it greater than 90? No, it's not. So it's not going to execute this part. Let me see if I could have a pointer or something. 1 second. Oh, yeah. So this code is no, it's not going to point this part. And then it tests if it's greater than 80. 85 is indeed greater than 80. So the machine's going to go, I'm going to print out a B. But the code doesn't stop here. And then the machine tests if score is greater than or equal to 70. That's true. So it's going to print out C or lower. But if you think about it, a score of 85 is a B. So we shouldn't print this one, right? So this code is the wrong one. We use the wrong method. We only use the if statement. That's wrong. Now let's look at the correct code. It's very similar to that one, except we use the else if. We use else if and else right here. So what this does is that this whole block of code will give only one answer no matter what. Like, for example, this would, as I say, this would ensure that only one output will be printed. So it doesn't matter what you get. So for example, if a student gets an 85, we test if it's greater than or equal to 90, which is not. Then we test the else if, and this executes to be true, and a B is printed. Since this code is already being satisfied, nothing else is gonna go. So the program is not gonna go to this part and print like C or lower. So basically, if it stop right, if a student gets like a 95, it's gonna print out the A, and this code won't even run. So that's what's the difference between the if else and only the if statements. Of course, sometimes you will want to use if statements as well. So it really depends on what you really want the code to do. Let's see. I think we're a little bit behind, but we're gonna go back to the practice if we have time. Next, we have the concept of loops. So it is another like very, very important topic, and the main purpose is just to repeatedly doing something without having to use repeating statements. So there are two main ones. One is the for loop, the other is the while loop. Let's first look at the for loops. So what it does is execute a block of code a specific number of times. So the structure looks like this. For, this is the declaration. You could kind of ignore that for now, but that's declaring that A is an integer. So this one, this part would be declare a variable and give it an initial value. Like for example, when you're counting, you can say, oh, I want to count to 1. So this will be 1. And if you want to count to 2, this will be 2. I'll count from 2. And the second one, a smaller than or equal to 10. This basically tests if the condition is still true. If it's true, the loop is gonna run again. And if it's not true, the loop is gonna stop. So it basically determines when will the loop stop running. For example, if you want to stop at 10, stop run 1 and stop at 10, you would put this value to be a 10. Finally, the a++, this part means that a would increase by 1 every time the loop executes. You could kind of see that as a counter. Like for example, you do it once and the program just say, oh, he or she did this code once. Let me count it for her. I'm gonna count it to be +1. So after one loop, a instead of being 1, it will now be 2 because we have this little counter counting for you. And then after we use a bracket, that's the formal way you are supposed to write it. And then we have some code. Oops, any code basically. So let's see, why do we need to use for loops? So let's imagine you are playing a game where your goal would be to kill the final boss. First, let's say I want to attack it 10 times. So without using the for loops, you're going to have to tell the computer to attack 10 times, basically. If your attack is to click, let's say Q, you have to click the Q 10 times, which is really like tiring. That's what the, of course, like sometimes the program, you can tell the program to do it 10 times for you. But that would be like really inefficient because why do you need to do so many repeating statements when you could just solve it with a loop, right? So with for loops, all of these long code, let's assume that they're codes, okay? This long code could be solved with like this very, very simple loop. So it has the same effect. So basically we start with, we start with the first attack. So a is equal to 1. We're attacking for the first time. And then we increment a by 1. Now a is 2. And then we attack the second time. And then we continue adding all the way until a is greater than 10. Oh, I should add something at the bottom, but like assume that after we attack the 10th time, and then a has to be incremented, right? That's the rule for loops. Every time you execute the code or you run the code inside, this a will be increased by 1. So after 10 times, a will be 11. And then this will come into place and say, oh, wait, a is not smaller or equal to 10. A is greater than 10. This is false, so I should stop executing it. Therefore, the code ran 10 times with just a simple loop. And you could control like how many times you're gonna like run it. You could change this to 15, then the code is gonna run 15 times. Or you could say, oh, I want to start on my like second attack. So you could change this to 2. So this will only attack 9 times. That's what's the benefit of a loop. We're still gonna skip the example as well. Let's come back after we finish with everything. Then we have something called a while loop. So a while loop executes block of code only while certain predefined condition is true. Basically what it means that as long as the initial condition is true, the code is going to continue run all the way to infinity or until the condition becomes false. So that's what the structure will look like. While something's true, we add some code to it and then we close it up. So let's look at a similar example. Imagine you are playing the same game, but now you want to keep attacking until you ensure that the boss health is 0 or less, which means you're successfully coded, which is the goal of most video games or games you play. If we don't have the while loop, we'll have to like manually attack it like a lot of times. because we don't know when it will die. Like we're not sure like if it's gonna die within like 5 hits or 10 hits or 20 hits. So we have to continue to do it, or do it a lot of times so we can make sure that we could win the game or if we could kill the boss. That's gonna be like very inefficient because you don't know when it will die, and it's gonna take so much of your time, and it might not even work out in the end because you haven't attacked it enough of times. So, but if we have a while loop, it's gonna make everything a lot easier. So we're just gonna say while the boss health is greater than 0, which means if the boss is alive, then we attack it. So if the health drops to 0 or below 0, we killed it. So there's no use to continue attacking it. Why should we attack it if we already killed it and won the game? So this ensures that minimal amount of code will get executed in order to complete a specific task. Of course, for this one, I could say Ion Call attack like 1,000 times. The boss will definitely be dead. That's true, but then you're gonna have like pages and pages of code. As for this one, you only have this like 3-line of code and you can achieve the same result. So after the health like drops below 0, the boss will be dead and you win the game. Let's have a better visualizing the whole thing with actual code. So let the boss health be 100 and every of your attack will minus 20 from the health. So over this part would be all the code we need. So first we declare a variable, say like, oh, let's use a variable called boss health, which is equal to 100. And while the health is greater than 0, which means the boss is alive, we would subtract 20 from the health. Oops, I used the wrong variable, but just treat it as like health. Just don't look at the boss part. Yeah, but you get the idea, right? So every time like while the health is above 0, we want to attack it, which is equal to minus 20 health. So after one loop, let's say we're going to here, or first into the loop. First, the boss health is 100. We check it with this condition. 100 is above 0, right? We can all agree on that. So the loop runs. And now we minus 20 from 100. That would be 80. The boss health is 80. And then we go back again because the condition is still true. We still want to run it. We test it again. Is 80 greater than 0? The answer is yes. We subtract 20 more from it, and now the health is 60. And then we continue doing that until after 5 loops. So after 4 loops, we only have 20 health, and we test it, it's still true, right? So we subtract 20 from it, and now it's 0. After that, we still want to run it because the statement is still true until there. But if we plug in 0, is 0 greater than 0? No, right? So the statement is going to be like, oh no, the boss is dead. You only have 0 health. Like you win the game. So there's no point in trying to attack more and make it to the negative because what's the point, right? So the code ends. The code will stop right here because you did not pass the test. And then the code ends and you successfully call the boss. That's basically how it works. We're just going to skip the example. I'm going to come back to it as practice in the end. And now we're going to have some additional keywords. These keywords are important, but you shouldn't focus like too much on it. Mainly focus on the 3 loops we talked about today. Not 3 loops, 2 loops and the statement we talked about today. So it's good to just know it. So what a break statement is, it causes immediate exit from the loop or statement. So it's usually used when you want to use a loop to find something and then exit the loop once you found it. For example, let's take a real world example. For example, you say you want to find a book in the library. You know the book is on like that shelf right there. You continue. You first pick. You start from like the upper left corner. You pick up a book, look at the title. If it's not the one, you put it back, and then you continue with that. However, once you found the book you want, you're like, ah, that's the book I want. It would be reasonable to break from your searching. Like you don't want to search anymore, right? You found your target book. What's the point of keeping looking at like 300 other books that you know will not be your book, right? Instead of looking through the whole library, you're gonna say like, oh, I'm done. That's exactly what the break statement do. So they're usually accompanied by an if statement, which tests if a condition is true, and if a certain condition is satisfied, you will break from the loop. Another is a continue statement, which skips the remaining statement in a loop body and proceed with the next iteration of the loop. So let's say, for example, you're using loops to print out a list of names, but you want to skip the fifth one for some reason. So you could use continue before the print statement and at the fifth turn to avoid printing that without disturbing the loops. This is usually accompanied with an if statement as well. So if, let's say, the iteration number or the round number is equal to 5, you want to skip that. You're not printing something. That's where you would use a continue statement. It will not disrupt like how the whole loop will run. Instead, it's just gonna skip that one round. So example might be like maybe you're counting with your friends, and you're counting with a computer, and you say, computer, I don't want to count any number that has a 5 in it or start with a 5. Then you can use a continue statement. So every time you encounter a number with a 5, the computer's gonna like, oh, don't count that. Let's skip that. So it won't just continue to the next loop. That's where continue statement will come in handy. Yeah, that's like all the topics we're gonna cover. We're gonna go back and do some more exercises that we skipped earlier, but I'm just gonna say what the homework will be today. So homework will be try to write a program that prints the first 6 multiples of 3. We hence use for loops for that. Write a program that prints hot if temperature is higher than 30 degrees, warm if temperature is less than 20 and greater than 30 degrees, and cold if temperature is less than 20 degrees. I would use if-else statements for that. And third, write a program that prints the value of variable a, starting at 1, as long as a is less than 30. A increments by 3 every loop. The hint would be to use while loops for that. So if you don't really understand about the homework, or like if you finish the homework and you want me to check it for you, just email me. My email is here, or just email me to ask any questions. I'll be more than happy to respond. All right, next, since we finished ahead of time, I would say it's best if we look at some examples that we skipped earlier. All right. So I would like some interactions between you guys. So feel free to open your mic or open your camera, or just type directly into chat if you are kind of shy. You could direct message me or just send it in public chat for everyone to see. So let's look at the second question. Where's my pen? Let's look at the second question. So would anyone want to tell me if 2 is equal to 2? Is this true? Type in the chat or or just say it out loud.
Yeah, it's true.
Yeah. And is 1 greater than 2?
No.
So if it's true, and then if you remember this little symbol, 2 lines, means or. So this is true, and this is false. True or false? What would the answer be? Take a guess. Oh, could you repeat it?
I think true.
Yeah, exactly. It's gonna be true because the this one, so you only need one condition to be true. All right, very good, very good. Now let's look at question 3. Let's look at the left side. Does anyone want to tell me what does this one output? Is it true or false? Just take a guess. It's okay to get it wrong. Just guess.
I think the first one's true.
False?
It is true. I think Iris is correct. Because if you see that 1 is not equal to 2, right? You know this part is false. But we have this little sign which means not. Not false means true, right? So this part is true. Also, can someone tell me, is 4 less than 5?
4 is less than 5?
Yes, that's true. So this one will be true. So what is this symbol means and. So true and true, what would the output be? If you're like, you don't want to speak out, you could just private message me. I could see the answer as well. I just want to check like if you guys understand the concept or not. All right, I'll give the answer. True and true will be true. So just a reminder, this AND statement will only output true if both the left side and the right side is true, which is correct in this case, right? So as for the last one, it's a bit more complicated, so I'm gonna go over it. So let's look at it a little bit at first. So let's look at the left side. 3 is greater than 4. That's false. We all know it. But then on the right side, let's see if this is true. So we go to the innermost loops, innermost parentheses first. 3 is equal to 3. That is true. 1 is smaller than 2. That is true. So true and true means true, right? So this part inside this parentheses will output to be true. However, we have this little symbol. Anyone want to tell me what does this symbol do?
Not.
Yeah, that's a not symbol, which means that this statement, not true, will be converted to false. So we have false and false. So false and false in any case will be output to false. And there we wait a second. Oh, this is true. Never mind, this is true. So true and false. So this is the or statement. It's gonna output true. So we can check our answers. We have false, false, true, and true. If you guys don't really still don't really get how it works, you could like go home and kind of read it. I have a step-by-step guide, kind of step-by-step guide right here. Just read it through. All right, let's see. Next practice will be with some if statements. Let's see where it is. Aha, here. So this is kind of like a fill in the blank thing. So let's say you want to write a program that reminds you Monday to Friday to go to school, Saturday to go to dance class, and Sunday to go to art class. So there's a variable date that specifies which day of the week it is. Basically says that that's kind of like your calendar or your alarm. Not sure if you guys have one of those that just like pops up and says if today's like a weekday, will pop up and say something, and if today's like maybe June 13th, it's gonna pop up and say something. This program kind of works like that. So we will use the if-else statements to see if it to make it work. So carefully read the conditions. Monday to Friday, go to school. Saturday, dance class. Sunday, art class. So would anyone want to try to see, tell me what will we put on the first blank here? This is just a little hint. It's art class today. At which date would the program remind you that you have to go to art class?
Sunday.
Yeah, that's right. Now let's look at the else if statement. It's another reminder that with else if and else statements right here, it will only output one result, which means that no matter like what you put in, it's only gonna remind you of one thing. So anyone want to tell me what do you want to fill over here?
Saturday for dance class, so Saturday?
We only put Saturday because over here we want to test, like if we test the date, the variable date specifies which day of the week it is. So if the date means it's equal to Saturday, like we say today's Saturday, dance class today will be printed out. That's exactly correct. How about the last one? Anyone want to try the last one? Just a hint that this would print out the reminder only, because we tested the conditions for Saturday. Saturday we tested for the Sunday, and what's the only thing left? What does the program want to remind us if it's like any other day other than Saturday and Sunday?
School.
Yeah, that's right. Here's the answers. Very, very good. Next, we're gonna look at, oops. Yeah, another example, but this time we'll be looking at for loops. There, let's see. So we have two programs right here. For the first one, we want to write a program that prints a number from 1 to 10. So we want to start from 1, ends at 10. What do we want to put here? This is the initial thing, initial counter. Or let's say, which number do I want to start from? Hint? Okay, so since we want to, this one will always be the initial number we want to start on. Since we say we want to count from 1 to 10, then this one would be 1. Would be 1 right here. All right, next. Ooh, I think I could write on it. Ooh, yeah, I can. So this will be 1. As for the second one, what would be the second blank be? So this is where we want to start, and this will be where we want to end. Any guesses?
10.
Yeah, very good. That would be 10. And here's the challenge. What do we want to print right here? Reminder that we want to print out the number from 1 to 10. But what do we print right here after each loop? Hence, it will be a variable.
A.
That's right. So like after one loop, so after each loop is gonna print out the value of a, and if since a increases every time, we're gonna print out from 1 to 10. If we have time later, I could show you this how this code is actually run like on a actually like in a program. So next, write a program that prints out the first four multiples of 2. Multiples of 2 just means 2, 4, 6, 8. That would be the first four. So again, what do we put here? Or actually for this one, we should look from here first. So I gave a hint that variable a will be involved with this. And then think the first four multiples of 2. So what should we put here? Do we write 1 or 2 or 3 or whatever? Which number should we pick for this one?
I think 2.
Yeah, that's right. So following this logic, we're gonna say we put 2 times a, which is our counter here. Where do we want to start? So the first number being printed will be 2. This will be the output. This part will be output. In order for the first one to be 2, what would a have to be initially?
One.
That's right. Okay, where's my pencil? Yeah, it'll be 1. Oops, that's 1. Following the same logic, where would we stop? We only want to print 2, 4, 6, 8. Where do we want to stop?
4.
Yep, that's exactly correct. Let me erase these things. And yeah, next. Oh, wait, why can't? Yeah, this will be the answer. So if you guys wanna like look over this at home, here's the answer. And the next thing we're gonna look at is the while loop. So let's say you want to write a program that continuously attacks a boss until its health, which is initially 20, reaches 0 or below. Your attack power increases by 1 each time you attack. This is like kind of like what we showed you before, like kind of like this one, like the last slide, but it has like one more condition is that your attack power increases by 1 each time you attack. So let's start from the first space. What should we put here? This is just like before you attack, before you do anything, what would the boss health be?
20.
Yes, that's right, 20. And our power is 1. So while the health is above something, what would this be? Just imagine like we want to kill the boss, right? So what condition do we want to test here? Let me call a different person this time. Megan, do you want to try to answer this? Or you could chat me your answer. How about Jing Jing? Do you want to help her? What should we put here? Go ahead, look over here. I'm not sure if it's my audio's problem, but I can't hear you. So if you want, you could chat the answer to me, and I could share with the class. Hint is right here. Hmm. Yes, that's right, Jingjing. It will be 0. The next blank is kind of challenging, kind of a little bit. So every time, so we have initially our power is 1, right? That's our initial condition. So every time we attack, we want to subtract the power from something. So power is basically how much damage you will deal to the boss. So what will this blank be? So oops, each time we attack, where do we subtract the damage from? JC, do you want to try? Or Iris, could you try to help her? Like maybe try to remember like oops, what am I doing? Like what we did here. What we did here. This is almost exactly the same loop. So what would this blank be?
I think it's health.
Yes, that's right. I'm just going to write an H because it's too small. And the last blank, this should be an easy one. Hint over here. Hint, hint. Caroline, how about you? What do you think? What do you think this blank would be? Hint is right here. Okay, how about Lucas? You try. What number should we put here?
Um, um,
So how much? 1? Did you say 1?
yeah.
That's right. So every time we we go through the loop, we increase our power by 1. That's exactly correct. All right. Let's clear the page. 1 second. Yeah, that's exactly correct. All right. Let's see how much time we have. We have like 5 more minutes. Just for like a little something fun. I'm gonna show like how the code actually runs on computer. Okay, so this is something that you would actually write a code on if you're actually gonna write it. I know that Brandon asked you guys to download something called Eclipse. I use a different one, but I think they work the same. So you know what? Let's type. Let me pick a good example. Aha, let's try this one. Oh my god, I just messed up. Just 1 second, I need to. So let's try a score of 85. Okay, why is this so weird? So this is what you would type if you wanna like to run that code. And then I run it. Give it a second. Look, it outputs a beep. This will be a window where you run. This would tell you how much time it took. It usually doesn't take like this long, but maybe it's because the first time running it, plus my computer is just bad. So next, let's say you did really bad, you got a 60. It will put C or lower. What did I do? Oh god. Yeah. Yeah, you can see that's how this code works. It's pretty amazing, right? Next, let's look at another thing I said we're gonna look, which is this one. I think typing it out actually will be faster. So you first type the initial condition, type the final condition, well, I mean final count. You add something to it, and then you print. So this is a really long print, but this whole thing basically just means to print something. Okay. Look, it printed everything. Like printed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I could add something else to it. I could say like printing done for this loop. As you can see that every time it prints this number, it's going to be followed by this statement because they are in this basically in the same loop. All right, I guess we could have time to do some more. Ooh, let's try to visualize the break and continue statements. We're gonna just use the same loop. For example, this is set, you can't change it. What if we only want to print till 5? So we want to test if a is less than or equal to 5. We would just want to print until 5, right? Then I would say like, 1 second. If a is greater than 5, so if it's bigger than 5, oops, too big, we want to break. Else, I think this is how it works. I haven't really like worked too much with the break statement because it's very, very uncommon. So I'm pretty sure this will work. Let's try it out. Yeah, as you can see, it stopped at 5 because once if the a is greater than 5, you break the loop, and then the loop is broken. So out of this whole loop, it's just gonna stop right here. Nothing else, nothing more is gonna be executed. Yeah, as you can see that this whole thing just ends. Doesn't matter, the whole thing just ends. Maybe this isn't a good example. I actually even add this part in the way. Oops, sorry. Yeah, as you can see right here, the whole thing just ends. Next, let's see. Let's do the continuous statement. So this time we're gonna say if a is equal to 5, instead of breaking from it, let's say, oh, I want to skip this loop. So what continue do is like if test a is equal to 5, it's gonna skip everything below it and just say, I'm starting a new loop. So it's just gonna go back and then start a new loop. Let's see what this will output. Oops, that's my mistake right there. So never forget to take double equals if you want to test for something. Yeah, as you can see here, we print 1, 2, 3, 4, but we skip 5. So that's a good example of what a continued loop would do. 6, 7, 8, 9, 10. So we print everything else except for 5. And yeah, I think that will be the end of our lesson. So please do try to do your homework and either email it to me. Yeah, just if you finish your homework, you could try to email it to me. Or if you have any other questions, just email me as well. I check my email like at least twice a day. So yeah, I will respond to your quick questions as soon as possible. So yeah, I guess that will be today's class. Everyone have a nice day or nice night. I'll see you guys maybe next time, maybe like the week after next week. Bye. Guys are free to go.